Okay, intermediate. Chapter 7 opens up with linears, graphs, word problems, equations. So there's a lot of information, but only a little bit of it is relevant. So we start out with interpreting bar graphs and line graphs, but we'll primarily focus on line graphs and linear equations in two variables. So a normal equation in two variables has an x and a y, so it's ax plus by equals c, where a, b, and c are real numbers. A and b can't both be 0. Solutions to the equations get written in ordered pairs, and you can make a little rectangular grid with quadrants 1, 2, 3, and 4. The horizontal axis is typically labeled the x-axis. When we talk about x-intercepts, they're along the x-axis. Vertical axis is the y-axis. Y-intercepts are along the y-axis. Your ordered pairs are always x then y coordinates. X is how much you're left or right. Y is how much you are up or down from the origin, and the origin has a value of 0, 0. This is considered the R2 coordinate plane, which is a standard two-dimensional coordinate plane. And the ordered pair can be graphed on that coordinate plane, but it also represents the solution possibly to an equation. The graph of an equation is a set of all points that satisfy a particular equation. So the idea for a line that has x and y is that whatever x is affects what y can be most of the time. So it's not that there's an infinite number of solutions, but not everything is a solution. Just as I said, the x-intercept is a point on the x-axis, which is going to be some value for x and 0 for y. The opposite for y-intercept, 0 for x, some value for y. And the horizontal line, the x-axis, is also the line y equals 0. The vertical line, that's the y-axis, is also the line x equals 0. So I'm going to focus on the primary goal of this, which is to graph linear functions, complete each ordered pair, and then plot the ordered pairs and graph the line. So we have the equation 3x minus 4y equals 12. It first wants us to plug in 0 for x. So 3 times 0 minus 4y equals 12. Anything times 0 is 0, so we just end up with negative 4y equals 12. Divide by negative 4. Y is negative 3. So 0, negative 3 means I go left to right 0 and down 3 to plot my point. Down there. Now it wants me to plug in 0 for y. 3x minus 4 times 0 is 12. Well, anything times 0 is still 0, so 3x equals 12. For 3, x is 4. So we have the point 4, 0, which is 4 to the right and nothing up or down. The last one it wants is to plot negative 2 for y. So 3x minus 4 times negative 2 equals 12. It's 3x plus 8 equals 12. 3x equals 20. So x is 20 thirds. Okay, so 20 thirds is for x that goes with the negative 2. That's a little more than 6. 1, 2, 3, 4, 5, 6. It's a little bit off there. Wait a minute. Something wrong here. Did we plug in right? 3x minus 4, 3x plus... Oh, subtract 8. My bad. 3x equals 4. X equals 4 thirds. So it's not 20 thirds, it's 4 thirds. So that didn't make sense. 4 thirds is a 1 and a third, negative 2. And we can connect all of our points to get a line. Really, you only need 2 points to make a line, but if you want to make sure, you can plot in more points than that. I apologize for the math error, going too fast. But that's the idea behind graphing. All you need is 2 points. Usually the two easiest to plug in are the zeros, or to get it in y equals mx plus b form, which we'll talk about a little bit next. Particularly in the next section, we talk about the y equals forms. For now, we're just going to practice plotting the zeros. and then using those two to graph when we can. So 2x minus 4y equals negative 8. Again, plug in 0 for x. 2 times 0 minus 4y equals negative 8. So negative 4y equals negative 8. Divide by negative 4. Y equals 2. So that's the point 0, 2. Plot it. Now we plug in 0 for y. 2x minus 4 times 0 equals negative 8. So 2x equals negative 8, and x equals negative 4. Again, that's the coordinate point, negative 4, 0. And then you just connect the dots on a straight line. Now, there are some situations where this doesn't always work. If you only see a y or only see an x, like these two, you just get that by itself. Y equals negative 4. Now, we talked briefly about it at the beginning. A y equals line is just a horizontal line. You can find where y is negative 4. There's no restrictions on x. It doesn't say anything about x. So once we go to negative 4, we can simply make a horizontal line. All y equals lines, y equals a number, are horizontal. X, same thing here. Divide by negative 3. X equals negative 2. You find where x is negative 2, and instead, x equals lines are vertical. So keep that in mind, that if you don't have both an x and y, then you'll have some special lines. What about if you're, let's look at number 8. What if your equation doesn't have the x and y on the same side? If you're finding the intercept, it's still the same. You still plug in 0 for x or 0 for y. So let's start by plugging in 0 for x. Y equals 1/2 of 0 minus 5. Well, anything times 0 is 0, so y equals negative 5. So this is the point 0, negative 5. Plot it. Now when you plug in 0 for y, you get 0 equals 1/2 x plus 5. Subtract the 5, minus 5. Add the 5. 5 equals 1/2 x. And then to get rid of a 1/2, you multiply by 2. X is 10, which is off the graph. But we can still find that it's 10, 0, and we know it's somewhere out here. And so that's what the graph would look like in this case. Now there are other types of questions you might get. Like decide whether something is a solution. All they want you to do is plug it in and see if it actually does equal. So is 4, 2 a solution to 2x minus y equals 6? Simply plug in 4, 2. 2 times 4 minus 2 for y equals 6. Is this true? Is 8 minus 2 6? Yes. If it's yes, then it is true. But compared to 11, is 5, 2 a solution to 5x minus 3y equals 15? So is 5 times 5 minus 3 times 2 equal to 15? Well, is 25 minus 6 15? Only if 19 is equal to 15. No, so this is false. And we will finish this section in the next video.